Have you ever considered how a single teaspoon of matter could weigh as much as a mountain? Welcome to the extraordinary realm of neutron stars, the universe's ultimate extremes. Neutron stars represent a fascinating paradox. They're the smallest stars we know, yet they pack a punch that's truly out of this world. Born from the cataclysmic death of larger stars, these celestial bodies hold secrets that continue to baffle and astonish scientists across the globe. Imagine a star 20 times more massive than our Sun, collapsing under its own gravity during a supernova explosion. The core contracts so intensely that protons and electrons merge to form neutrons, giving birth to a neutron star. But what makes these stars stand out? Firstly, their size. Picture a sphere approximately 12 miles across. That's smaller than many cities on Earth, yet this sphere contains more mass than our Sun. It's a level of density that's hard to fathom. A sugar cube-sized amount of neutron star matter would weigh about 100 million tons on Earth. Secondly, these stars are spinning powerhouses. In their youth, neutron stars can rotate up to 700 times per second. Their immense gravity pulls surrounding matter into a disk, which then spirals into the star, leading to faster spin rates. This rapid rotation, combined with a strong magnetic field, creates jets of matter and energy, making neutron stars some of the universe's most potent energy sources. Lastly, neutron stars are cosmic laboratories. They offer us a window into the nature of matter under extreme conditions that are impossible to recreate on Earth. The pressures inside a neutron star can be up to 2 times greater than that found at the center of a black hole. It's here, in these extreme environments, that we can study the fundamental properties of matter and space-time. However, despite their immense power and intriguing properties, neutron stars are not invincible. They are subject to their own life cycle. When 2 neutron stars collide, they can form a black hole, or they might explode in a kilonova, an event so powerful it creates elements like gold and platinum, scattering them across the universe. In summary, neutron stars are celestial powerhouses born from the explosive death of larger stars. Small, yet incredibly dense, they spin at mind-boggling speeds, acting as cosmic laboratories that offer a unique glimpse into the extreme conditions of the universe. Yet despite their power, they too have a life cycle, with their death leading to the creation of black holes, or sparking powerful explosions that seed the universe with heavy elements. Neutron stars, thus, are not just fascinating celestial objects. They are key players in the cosmic drama, helping to shape the universe as we know it. Their power and mystery continue to captivate us, reminding us of the infinite wonders that lie beyond our earthly realm.